Welcome back to the hyperbolic coding time chamber. The hyperbolic coding chamber. Okay, it is day 99, a momentous day, mostly because it's day 99. Tomorrow will be day 100, which is pretty cool to think about, and it's kind of funny also to think about because it actually doesn't. It's very strange. It doesn't actually feel like we did it for 100 days, even though we have the proof. But it's just interesting because, yeah, somehow it feels like it's been longer than that. So yeah, but there's a lot of interesting things. So maybe we'll make our first YouTuber video like, oh man, our first YouTuber video. It'll be something like this. I'll be like, okay, if you see the thumbnail and it looks like this, and it's like me pointing at like, I have to play the game. So it'll be a necessary evil. So it's gonna kill me, but it is a necessary evil. But we'll save that for tomorrow. Today is day 99, and I think that's a cooler title, 99 Days of LeetCode, or 100 Days of LeetCode. But either way, yesterday we were still finishing up a weekly contest. Didn't go so well, but I was just talking to Thomas, and it seems that I also talked to Thomas in the Bearer of Truth. It looks like a BFS or DFS OEvent solution does not get TLE, so I'm going to go ahead and say that the reason, because the Bearer of Truth also did it with the BFS, and I'm relatively certain we used the same methodology. So it didn't work on our end because I think the Bearer typically uses Python, so I'm pretty sure that access to a deck or a similar data structure was available. So that being said, that is besides the point. We have a comment from Tantalulu. I think I'm just gonna build a Raspberry Pi that will make me coffee as my alarm and have my coffee machine in my bedroom. It's loud too, but coffee will make sure I won't go back to sleep. True. Also, I feel like that nice warm smell of coffee, it might just make you go, might just wake you up. That'd be pretty cool. I also that's actually pretty dope. That is pretty dope. I am excited about this build. I also thought of a machine. Imagine this, okay? Back in the day, hundreds of thousands of years ago, they used to have inventors write up these crazy machines that just seemed otherworldly, okay? I have an idea for a machine, right? It's called the modern alarm, or the sleep extraction unit is what I call it. The sleep extraction unit, the SEU, and it's actually just a bed mounted upon some sort of elastic mechanical system, ideally with enough force to like launch or catapult you out of the bed. So when your alarm wakes up, it would just catapult you out of bed. Also, maybe, yeah, that would work. I think that might work. Or we could create a bed, right? A regular bed, and then we could attach something like a ceiling, like, a regular ceiling, and it would have large, like, cone-shaped spikes that when your alarm starts actually going off, it would slowly descend down into you. And so maybe that perilous intent might inspire me to get out of bed, but we'll see. But that's a pretty cool build, so I'm excited for that. And then our homeboy Thomas Wong says, can't wait to race you in a weekly contest. Me too, brother. So I'm excited about this. I'm excited to see this. I'm gonna be honest, I mostly do easies, and I just try to learn from the gang in the Discord, Thomas, the Bear. So yeah, but I'm still gonna get in there. I'm gonna enjoy this one. So I don't know when days the weekly contest is at. I think it's Sunday. So we'll have to change the time we do it on Sunday to line up more closely with this, which kind of, I'm gonna be honest, is a little rough or unfortunate, but it'd be nice to get into the aspect of just doing like a weekly contest. That seemed pretty like fun. So that'll be pretty cool. And yeah, that would be pretty dope. So be there or be square. So that'll be pretty dope. Other things to mention, I've been slacking on my ADM reading. I'm going to be honest. I've been slacking on it. I'm wondering if the book, I mean, maybe it can, yeah, I'm thinking maybe it still can be read front to back. Maybe we'll just do that anyway. Maybe we'll just read it front to back just so we know that we've touched at least everything in the book at least once. But I'm wondering if it just works better as a manual. Like when we get stuck on a problem, we'll just consult the manual. You know, that way we can always, we're learning in the context of a specific problem. So yeah, I think that might be the way to go about that. But yeah, other than that, reflections, I seem to be able to, the alarm me thing is not working. So it might be time to draw new sticks. So what I've been doing instead has been putting my phone away from the bed so that I actually have to get up to stop my alarm. And this helps. So just adding a little bit of barrier definitely helps. So yeah, I think, yeah, that seems to help right now. So I'm wondering though, because these things are always a journey. So if we're speaking about, you know, a system that is currently working, why is it working? Right? And I think the reason it could be working is that right now I'm definitely motivated to get up early. I guess my worry is that in the future, given a different set of scenarios, different circumstances, maybe my brain juice is lacking, that maybe the motivation that has been tipping the scales and helping me get out of bed will not be there. That's why I initially went for something as like aggressive or abrasive as alarmy, but yeah, it just remains to be seen. So I'd like to put the system through its paces. I don't know if this one is as resilient as I think it will be. But I will say the other added benefit of putting my phone away from the bed is that it's less browsing before I go to sleep. So I'm going to sleep faster. So all in due time. Many things to be done. Many things to be done. I also realize these days I'm just kind of treating the daily LeetCode as like a daily diary. So it is what it is. I think it'd be cool to look back and see just what I was thinking about at the time. And also the videos, as you can tell, I try to keep as low effort as possible because, you know, doing LeetCode every day is significant, is difficult. I wouldn't say it's that hard anymore just because I'm so used to exposing myself to the system now. It's a lot simpler. But ideally, yeah, I want to get through all the easy so we can do mediums. And we used to do mediums before, but just because now I'm trying to balance other learning, it just doesn't quite make sense. And yeah, the easies are fun. We learn a bit from them. So yeah, I've just kind of been using the videos as a daily, as like a reflection space. So yeah, it is interesting, and it reminds me of a quote from a book, I think, and it was called Why Write? And I think the quote, or it was like a little story. It was about a spider that was hanging atop some structure, or it compared writing to a spider. You know, a spider expunging, you know, an infinite length of thread into the void to spin together a home. And I think what the writer was getting at, I think he said, was that the story is right. It touches upon something like an intimate part of writing, which is that what the writer puts on the paper comes from within. And all this to long-winded way of saying that, yeah, you know, I'm just kind of putting this out there. So, you know, when I reflect on why this is happening, I think I'd just like to complete the challenge. But in another way, I sometimes wonder why, if I'm focused on completing the challenge, why I add these intros in the beginning. So, yeah, it's just an interesting thing to think about. But who knows? More days to come. And, yeah, this will be day 99. So, we're just going to jump into it. So, let us jump into it. So, we have a bunch of easies lined up. Hopefully, we can bang through them while learning. That would be the goal. And then, yeah, I'm just going to jump into it as per usual. Our time limit is already going, but that's not actually what we're going to do. So, also, I should have made my camera bigger, but it's okay. So, we're just going to jump into it. And, yeah, shout out. Make sure you join the Hyperbolic Coding Chamber. Shout out to all the people who joined recently. There was a pretty cool person who joined yesterday. We were talking about some keyboards. So, make sure you join. Actually, I'm pretty sure that it might be Tantalulu, because the icon looks similar. If it's not, apologies. If it is, welcome to the Discord. And yeah, I'd like to make the Discord more interesting, just so we can exchange some ideas, but we shall see. So let's jump into it and let us begin. So we have power of 2. Let me see if everything makes sense here. Looks like everything makes sense. Is my text kind of small? It's a little bit small. I've also become really frustrated with the tooling. So I think I need to swap this keyboard out for one that I'm more comfortable using and switch caps lock. Actually, I'm just gonna do that real quick. I'm used to caps lock being control, and that really messes me up. Oh. You know, we don't have the time today, so I'm just going to jump into the problems. I'm going to restart the timer. Everything looks good, and we'll fix it hopefully for the next stream. But our function is power of 2. And now, honestly, I think we might start doing this stuff in whenever we need access to a data structure. I think we're just going to start using C or C++. Maybe it'll just be cool to have it on hand when we need it. But we're going to say, given an integer n, return true if it is a power of 2. Otherwise, return false. So we're given an integer n, and we need to return true if it is a power of 2. Otherwise, return false. An integer n is a power of 2 if there exists an integer x such that n is equal to 2 to the x. Example 1, n equals 1. There is an integer x, right? 2 to the 0 will give us 1. N equals 16, right? There is an integer 2 to the 4, which will give us 16. N equals 3. There is no integer such that 2 to the x will give us 3. That looks like our constraints that n can be negative or up to 2 to the 31 minus 1. So, interesting. So, I think just to start, I think we can, I think there are a lot of problems that are similar to this. I think one thing we could phrase this as, right, we're looking for an integer, right, we're looking for an integer such that 2 to the x equals n. Now, if that's the case, right, we need to know what our search space is. Well, our search space is negative 2 to the 31 to 2 to the 31 minus 1. Is all the possible values of n. But if we're going to be doing a power of 2, I don't think there's any number there's any number that we can do 2 to the x for that will give us a negative number. So I think if our number is negative, it's just always going to be false, right? And so let's think about that. Is there anything such that 2 to the x gives you a negative number? If you do negative 1, 2 to the negative 1 gives you like, I think that turns into like square root, I think. 2 to the negative 1. Yeah, you get 0.5. If you do negative 100 yeah, you just get a really small number. So I think we can just say right here, right, return false if n is less than 0. Right, now that we know our search space is only going to be positive, right, now we can phrase it as a linear search problem, right? We just need to find x, right, well, our search range is going to be x up until n, right? And the reason, I'd say x, but 0 up until n. And if we do that, right, what we can phrase this problem as is, hey, search between the range of 0 up until n, up to and including n, right, and see if 2 to that number gives us n. If we ever pass that number on the way, we know that this number is not a power of 2. So, for example, n equals 16. Our search space is going to be 0 up to 16. Right? So we would start at 2 to the 0. We'd say, okay, is 2 to the 0 equal to 16? No, it's equal to 1. 2 to the 1 is equal to 2. 2 to the 3 is equal to 4. No, 2 to the 3 is 2 times 2, which is 8. Right? And then 2 to the 4 is 2 times 2 times 2 times 2, which gives you 16, which is true. Now let's just say the number was 17 instead. We would have gone to 2 to the 5th, which would have given us 32. And 32 would have passed 17, so we could return false. So we're going to set this up. We're going to do a bunch of checks, and if we don't fail any of those checks, we'll return true. We'll return false, right? Because we're going to be looking to exit, and if we can't exit early, actually, I think we're going to exit during the loop, but we'll see. So now we can just do, right, let's say 0, right, going up to and including n, dot each do num, and then the goal here is going to be, we're going to say, hey, if 2 to the n, 2 to the power, right, equals n, then we're going to return true. And then we're going to have an else, right? Else if 2 to the power is greater than n, we're going to return false. I have a feeling that this should work, but we'll see, right? Let's see. We're going to go from 0 up to and including 16. 2 to the 0 does not equal n. So we keep going. 2 to the 1. Right, so I think let's try the example test cases. So this one is not that good because I think it's going to be pretty much worst case scenario is that I think there's no way that we can do 2. There's no number such that we can do 2 to the n and get n. Except for, yeah, there's no number. Even if you did 2 to the 0, you get 1. 2 to the 1, you get 2. And there's just no number that would be the same. So I think at best, you end up actually just doing visiting, or the search space, half the search space. So worst case, we usually drop that. So I think this would be linear time. But I think you could also phrase this as a binary search, since our search space, right, is 0 to n, which is already ordered and sequential. You could layer a binary search on top to get log n time. And so, yeah, I don't see why not. We could just try that version real quick. So we're going to switch this around and do log n time. And to do that, we need to do a binary search. So we typically have a range. We calculate a pivot. And then based on that pivot, right, we'll either choose one of the two ranges. And then we end up having our search space on each iteration, hopefully. So our left is going to start at 0, and our right is going to start at n, right? And this is going to run while they haven't passed each other, and while they're equal to each other. Right? And so we can keep some code here, right? So we can now calculate our midpoint, right? And so our midpoint, which is our pivot, will be left plus, I think it's right minus left over 2 floored. So let's just say we have 0 and 16. We'll do 0 plus 16 minus 0, which is 16 over 2 is 8. Floored is index 8. So I think that should work. Right, but our pivot is actually also going to be our power, conveniently. So we'll just name it that. We'll still call it the pivot though. And then I'm going to say if 2 to the pivot equals n, then we want to return true, right? Else if 2 to the pivot is greater than n, right? So if we do 2 to the pivot and it's greater than n, then we're going to want to skip searching the rest of it, right? So for example, if we're searching for, let's just say 16, and we do 2 to the 3, which gives us 2 to the 4, or 2 to the 8, right, which gives us some arbitrarily large number, we know that 2 to the 9, 10, 11, 12, 14, 15, 16 is already going to be bigger. Because if 2 to the 8 is already bigger than 16, there's no point searching 2 to the 8, 9, 10, 11, 12. So what we would do is, instead of returning something, we want to change our partition range, and we'd say right is going to be equal to pivot minus 1. Then we're going to have another else if, which we're going to copy. We're going to say left is now, it's going to be very similar, right? If 2 to the pivot is less than n, so we do the same thing. If we're looking for 16, right? If we're looking for, let's say, 300 or something, and we do 2 to the 5, right? 2 to the 5 is like 64, I think. So if we know that 2 to the 5 is 64, which is less than 200, there's no point checking 2 to the 4, 3, 2, and 1. So what we'd like to do is take that midpoint, our left was here, we're going to take this midpoint, our pivot, which we found when we were our left point, to 1 point past it so that we skip searching everything on this side. And that's going to be pivot plus 1. I think there's one thing we have to check, right? And we'll be almost done with this problem. N equals 3. Let's just say we did 3. Our range is going to be 0 to 3. 0 is less than or equal to 3. Our pivot's going to be 3 minus 0, which is 3, divided by 2 is 1.5. Floored is index 1, right? We're going to say 2 to the 1. Does that equal 3? No. 2 to the 1 gives us 2. Is that greater than 3? No. 2 to the 1, is that greater? There's always an edge case here about how it lands on the number, but we'll try it for now. Seems to work with the test cases. Wait, I knew something was off when we first ran this. Because the time complexity is very similar. How are we getting TLE? It should take like at most six halves to get to what we're looking for. Wait, something's wrong here. Or maybe nothing's wrong. Something feels wrong, though. There's no way. Something's got to be wrong. There's no way we could get TLE. If we do 32,767. Right, 2 to the 16. So we have that. We do like 2 to the 16,000, which is way too big. Is equal to pivot minus equal 1. Wait, right would be equal to pivot minus equals 1. Yeah, it's counting down. What is going on here? Oh, maybe it's a parenthesis thing. Oh, that's interesting though. I wonder why that is. Yeah, this is what we're expecting. Should be it shouldn't. Yeah, it shouldn't take too many halves to get to. So this one is even slower though. I guess the worst case, I think we might get better performance on larger numbers. This is one of those weird cases where the number of it is just faster to do a linear search because I guess the numbers grow so quickly. But actually, it doesn't make any sense because this takes us about this. Oh, now never mind. I see. It's probably because we're doing puts pivot. I think that's why. No. That's just strange. I don't know why that is. Something seems wrong. Something seems off about this. Why would it be so slow? This should be log of n. Should be log n. Maybe something's wrong. Left plus right minus left over 2 dot floor. I have to look this up in another. Yeah, that's so strange. But we'll let it be. And I think the question had a follow-up. Could you solve it? Could you solve it without loops or recursion? Without loops or recursion. I don't know if there's a way to solve it without loops or recursion. Maybe there's two numbers you can do modulus for and return it for. So, for example, if we have I don't think we can do mod 2, because if we do, I feel like there's a certain group of numbers that all fit into, n is a power of 4, because 2 to the 4 equals 16. If we listed out all the powers, it'd be 1, 2, 4, 8, 16, 32, 64, 128, 256, and so on. I don't think you can just do one. Maybe it's a case where we can say if n mod if n equals 1, 2, 4, or 8, it's definitely a power So let's try that. Let's just say if n equals 1, n equals 2, n equals 4, n equals 8, n equals 16, return true, and then at the end we can do return n mod 16 equals 0. Should work. 48. Output true. And maybe it's maybe we have to include all of them. Maybe we do n mod 2, n mod 4, what if we include 2 more like this? What if we add, we had 4. Okay, what if we add, I don't even know if this is a good idea. $16. Okay, what if we swap it for 32? N mod 32 equals 0. So it just pushes the number up. I'm sure there's, maybe we could shift it 32 times. It's a power of 2. It's a power of 2, and it's a 32-bit number. That means we can have 32 ones. If it's a power of 2, what do all these numbers look like? Well, let's just default to 8 bits. 1, 2, 3, 4. One would look like this, and then I'll make 4 more columns, 4 more versions. There's 1. 2 looks like this. 4, 1, 4 looks like this, I'm pretty sure. 8 looks like this. 16. I think you could just encode. Maybe you could just literally encode the first 32 powers. The first 32 bits. Maybe you could just do that. $32 bits. It's only 32 numbers. So I'm just going to do that. And I feel like that would count. N equals n mod 32 equals 0. And n mod 64 equals 0. And n mod. This is a lot of work, bro. Yeah, let's just check out the solution for the non-recursive version. Obvious login times solution. Instead, the problem will be solved. Said the problem will be solved in constant time with help of bitwise operators. Ideas discuss such bitwise tricks, how to get such isolate the rightmost bit. Which is not a power of 2 has more than 1 bit in its binary representation. Interesting. That was pretty cool. I see what they're getting at here. I see what they're getting at. That was pretty cool. So we'll just go to the next problem. Spend a lot of time on that problem. This one's called shortest word distance. Given an array of strings. Given an array of strings, words, dict, and two different strings. So given an array of strings, words, dict, and two different strings that already exist in the array, word 1 and word 2, return the shortest distance between these two words in the list. So we're given an array of strings, words, dict, which is this array here. Practice makes perfect. Coding. Right, coding makes practice. Return the shortest and two different strings that already exist in the array. Word 1 and word 2, coding and practice. Return the shortest distance between these two words in the list. Okay. So we're looking for the distance between, the shortest distance between coding and practice. 1, 2, 3. Oh, interesting. You can even wrap around the end. Practice makes perfect. Coding. The word 1 is makes. The other word is coding. Okay, there's always at least two words in the words dict, and 1 is less than or equal to the words in word dict are between the range 1 and 10. Only lowercase English letters. And word 1 and word 2 are definitely in words dict. Word 1 does not equal word 2. That's a good thing actually that they mentioned. Interesting. So they're not saying that the words in words dict are unique, so it's possible that there could be many of those words in there. So if we want to find the shortest distance, I'm thinking maybe a linear time there's an n squared solution here where we just keep searching between both, and then we just do an n squared solution. So for each word, if it is equal to word 1 or word 2, then we'll just do a n squared iteration and just take the smallest value. So maybe we'll do that just so we have a solution first. So we'll do this TypeScript for some reason. We'll do n squared version, okay, and we just want to iterate over all the words in words dict. So we'll just say 0 going up to words dict dot length dot each do outer and then we'll name this one inner, and then we'll just say shortest distance is going to be equal, we want to keep the shortest distance, and we're going to be updating this value constantly, but we don't know what the minimum value for shortest distance could be, so we're just going to set it to float positive infinity. And so we'll say if words dict sub outer is equal to word 1 and words dict sub inner is equal to word 2, and we actually don't, I'll make this slightly smaller, don't need these parentheses, we'll say shortest distance equals shortest distance, and we'll do outer minus inner dot abs dot min. Then we could return shortest distance. So let's try this. Dict length we're going to go up to excluding the last element. Outer is going to be equal to practice, right? And then we're going to start again here. We don't want, we know that the words can't be the same for the constraints, but let's just set it so that we actually do want it to start at the beginning. So that's actually okay. I don't think this works. I was thinking we should put this at inner, so we start at inner plus 1. We actually don't want that because we want to check the entire array for every word because it can wrap around. So if word underscore dict sub outer equals word 1, which is practice, which it does, and words dict inner equals word 2, 0 does not equal practice, makes doesn't equal practice, perfect doesn't equal practice. Wait, word 1 is coding. Oh, okay. So we actually run quite a few times until we got to coding. And then we get coding, and then we start practice. Then we get index 0, 1, 2, 3. 3 minus 0 would give us the absolute value of that. So I wonder if you get TLE. So n squared is unacceptable. So it's good to know that. So it's unacceptable. I think I have a linear time solution. So I think there's ideally, I think what we can use is a most recently found word 1. So for example, word 1 is equal to coding. And it actually doesn't work great for example 1. But let's just say word 1 is equal to makes, right? We iterate through until we find the closest makes. The closest or the most recent makes is at index is 1, right? And now that we have an element in that array, we're going to go and see if we can find coding. So we find coding, and so we just take the shortest distance between the word 2 that we're at and the most recent makes we found. So that should be the shortest distance unless we can wrap around right? So then, wait, we have makes at over here. Okay, so I think we do have it. I think there's only two cases, right? Either word 1 is early, right, and word 2 is later. So we have coding here. Word 1 is coding, right? And the word 2 comes later, which would be, oh, I mean, right here. The word 1 is makes, which means that word 1 comes early, which is here, makes. And then we give word 2. We get word 2, which is coding. So later on, we'll find that, oh, our most recently used makes was this one away. And in a way, we kind of end up skipping this one right here, right? But we'll run this twice to do 2n. And I think if we run it twice, and what we'll do is we'll swap word 1 and word 2, right? So now word 1 will be coding. So we finally find coding. And then if we try to find the most, now we can check for the most recent makes. All right, we'll find that. And then we will have it. Most recent makes. So let's try that version, and I think it should work. Let's make sure it works for these other examples. It works for example 2. Is work for example 1. We have code 1, which is coding. Try to find first. We try to find coding, which is 0, 1, 2. 0, 1, 2, 3. All right. Then we try to find the most recent. Practice. And we don't before getting to the end of the array. So then we try and swap the words. We find practice first, and then we find coding, and we still end up with the answer, which is 3. So let's try 2 versions. We'll try 2 pass with swapping words, and then we'll also try we'll try a circular buffer version. So the first version, the 2 pass with swapping words. I guess we could just make a function called def find short will pass in words dict with word 1 and word 2. It's kind of mimicking the parameters here, but it is fun. And then we want to first find word 1, right, and then find the closest word 2. And if we don't find it, we'll just return. So we'll just return. We don't want to keep writing shortest distance, so I'll just write shortest equal to float infinity, and then we just want to iterate through words dict dot length. And down here we'll return shortest. And then the goal will be, first we have to find word 1 IDX, which is -1, and then word 2 idx, and then we'll say if word 1 id, if words dict sub word 1 idx equals word 1, then we'll set word 1 idx equal to idx. And then we'll say if word 1 idx does not equal -1 and word 2 idx does not equal -1, then we want to set shortest equal to the smallest distance between shortest and word 1 idx minus word 2 idx dot abs dot min. And we'll say puts shortest. What do we say? What do we call it? We call it find short. And we'll just return that, just a random number, just to check if our answer is correct. I think it's uninitialized constant, and I think it has to be all capitals. So our output is 1. Are we running multiple test cases? Output, our std out is infinity, which I think is what we expected, right? Because we end up finding that we're looking for coding and practice, but we never find them in the correct order. Because word 1 is coding, we find word 2, we never find word 2, even though we find coding. But if we run it again with word 2 and 1 swapped, we still get infinity. I think I'm seeing why we want to actually use idx. Words dict sub idx equals word 1. Then we said word 1 idx equal to idx. And then if words dict sub idx equals word 2, then we said words 2 to idx. Doesn't make sense though, because the words we're starting with is coding and practice. So if we start with practice, I guess we're just checking on every iteration. So yeah, I guess we could find practice on the first iteration. I'm not convinced that this, if we submit this, it shouldn't work. That's what I'm thinking. It's gonna work with this one, but if we submit the remaining test, if we submit the remaining test cases, the test cases still might not catch it. No, that doesn't quite make sense. Why does that work? It should be much faster if we remove. Maybe it works because we end up always having the most recent of both on hand. And since we have the most recent of both on hand, we can always take the shortest distance between them. It's still pretty slow though. I mean, this would be linear time, I think, because we're just iterating through the array of words, and we only keep some variables that at most would just store 3 integers, so I'd say constant space as well. I wanted to do a circular buffer version, but ISO1, ISO2 is less than the minimum. This is the brute force we did earlier. Each time we find a new occurrence of one of the words, we do not need to search the entire array for the other words inserted with the index of the most recent occurrence. Time complexity is n times n, where n is the number of words in the input list and m is the total length. I see what they're saying. That's a good point, because we're doing string comparison. So it's not that simple. That would, okay, I see what they're saying. Interesting. So we have 9 minutes. Given a string num, which represents an integer, return true if num is a strobogrammatic number. A strobogrammatic number is a number that looks the same when rotated 180 degrees. That upside down. One is less than or equal to, so we always have at least one number. Num consists of only digits. Num does not contain any leading zeros except for 0 itself. That is an interesting problem. I think what we're seeing a strobogrammatic number. Well, if we list out all the possible numbers, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. I don't think 1 is strobogrammatic. We'll just do this one in TypeScript since it doesn't really matter. I'm going to return 0 or false. So I want to test a test case of 1. One is strobogrammatic apparently. So 1 is, what about 2? Definitely isn't, because when you flip it over, it wouldn't quite make sense. It wouldn't be the same. Okay. I think we can probably safely conclude that 3 is 1. 6 is 1 with a star. 7 isn't 1. 8 isn't 1. And 9 is 1 with a star. And 0 is 1. So pretty much any number that contains any of these numbers so if I use 2, 4, 5, 7, any number that uses 2, 4, 5, and 7 should be false, I think. So it's a bit tedious, but a necessary evil. And I think they're telling us something here because number is a string. So I'm pretty sure if it has a 2, 4, 5, or 7 in it, it's not strobogrammatic. If we have a 3, So I think one thing we could do to solve this problem, I think it's going to be a linear time iteration. And what we'll do is we can create a map, which is going to be a map of string to number, and then actually array of numbers. And what we're going to be working at, right, we're going to create a map, and for each number, so 1, 2, 3, 4, 5, 7, 8, 9, we're going to map it to the indices it exists within the string. So if we look at 6, right, we'd map 6 to index 0. And the goal of that is just so we can validate the number based on the strobogrammatic rules. So you can just do, I think we can do for const idx, or we're going to say value is going to be equal to if map dot has letter. If the map has a letter, then we're just going to map dot get the array for that letter. Otherwise, we're going to set it equal to an empty array. And we're going to say map, array dot push idx on, and then we'll do map dot set letter to array. Oh, it can't. Oh, wait. Maybe it's the opposite. Maybe it's letter then index. Argument of type string is not assignable to parameter of type number. Type string. Let me just print what both of these are. Oh, it's a type error, so it's not. I'm just going to say that is any. Okay. I thought there was a way to do this. Oh, no, there is. It's num dot values, I think. It's keys, values, num dot entries. Argument of type number. Okay, so now it's swapped, I think. Okay, finally, just a little reintroduction back in the type. So I should probably swap languages between problems. That'll probably make it easier. Do const array equals map has letter, map dot get letter, array dot push idx. Okay. Right, and then we can say if this will be our problem set of numbers. We'll say 1. No, not 1. We said 2. And actually, we can just say, we can just do it in here. Actually, if letter equals 1 or letter equals, I keep saying 1, it's 2, letter equals 4, or letter equals 5, or letter. 7. We could use an array for this. I'm just going to say return false. We're going to have more false checks, and then at the end we'll return true, but we just need a few more. So I think we actually should pass all the test cases, but I think our answer should still be wrong. So works out. So I think if you do 9, if you were to flip this upside down, you would have 669, which wouldn't look the same, but our algorithm would return true. Theirs should return false. Okay, output is true. Theirs should be returning false. So that makes sense. Basically for 8, wait, if we take 882 or 889, flip it over. Yeah, so I think if we have 1, 3, 8, or 0, even if you flip it over, it doesn't matter how you flip it, you're still fine. It's 6 and 9, I think. If you flip over a 6, and you have to make sure that 699. If you flip it over, you would get 669. Yeah, so I think the final thing we have to check is if they're flipped, right? So we'll take 6 and 9. 6's map in the array looks like this, and 9's map in the array should look like 1, 2. And to swap these, all we'd have to do is swap their array values. So one thing we can check, right? If our lengths diff, that's a false. So they should be parallel. So we can just add that check in here. We'll say if call 6r equals map.get 6, call it 9r 9, let's say 6r and 9r. Hopefully they both exist. And it if actually we can just do we'll actually need another quick check actually. I think if if neither exist, then we can actually just return true. And then now we'll know they both exist. Now we can just check if 6r.length equals 9. Right, if those values aren't the same, then we're going to return false. And they should be the same length array now, so now we can just iterate through the indices. So we'll say 6r.length, right, I plus plus, and then we should just have to check. So they should be a parallel array now, and if you flip them, then their values should have swapped. So if you were to flip it upside down, so if that's what should have happened, all you have to do is check if the mirror index, as we're always going to be a 6 through the array, we just have to check if our mirror index is a 9. If it is, then we're good. So the way we'd get our mirror index is we would say if 6r sub I, which is, well, we already know it's a 6, so we want to check if our mirror index, which should just be 6r.length minus 1 minus I equals a 9. We actually want to do 6r or not 6r, but the string or a num. But if it doesn't equal a 9, we'll return false. So I think that this, bro, what is going on? We'll return false. And then 669. Where do we have that? 669 is not a valid. So we do get false. And then for 6.9, I think this should work. Values of 0 and 1. They both exist. Their arrays are the same length. We start at 0. If 6r.length, which is 1, minus 1, which is 0, minus I, which is also 0, oh, I should have put, yeah. I kind of want to know exactly where I'm returning false. So it looks like it is here. So if I print, I have to go, if I just print num sub 6r.length, 1 minus I. Oh, does it equal 6? Ah, I see. Because we never... I think what we want is 9r dot length of it upside down. I guess 3 is part of the no zone, actually. So that's interesting. So our solution is fine, but I have to go. So I'll fix this one tomorrow, but I tried to rush through it to get it done fast in 7 minutes. But good effort anyway, but gotta run.